Lesson 3, simplifying expressions using the product property of exponents. In our new concepts, we learned that there are a couple different terms that we have to understand when we're dealing with exponents. One is that this is called a base of a power. The base is the larger number down here at the bottom in the basement of this problem, if you will. Then above that is the exponent, and that exponent is going to represent how many times you're going to multiply this number by itself. So this is 5 to the third power. That means you're going to multiply 5 times 5 times 5. You can multiply 5 by itself 3 times. That's what that exponential value offers us the opportunity to do. If you look at the example problems, it asks us to simplify expressions with exponents, in which you're going to practice writing those things out. 7 to the third power is 7 times 7 times 7, and we can calculate that by doing one at a time. 7 times 7 is 49, times 7 offers us 343. In the decimal version, notice the parentheses here. The decimal on the inside of those parentheses still means that you're multiplying by that value. The exponent 4 indicates that the base is the factor 4 times, so 0.3 times 0.3 times 0.3 times 0.3. And you would do that multiplication. Here's how Mr. Shane does that. 3 times 3 times 3 times 3, just because I know my multiplication facts without worrying about decimals. 3 times 3 is 9, times 3 is 27, times 3 is 81. Now when you're multiplying decimals, you have to factor in the number of decimal places that went into the actual multiplication. So we had 1, 2, 3, 4 decimal places, therefore we moved it from the end of 81, our answer, 1, 2, 3, 4 places. We've got 0.0081 as our solution. Another example within a fraction, when you have an exponent, that exponent actually applied to both the numerator and the denominator. So you can set that up and write it out just like this: 1/2 times 1/2 times 1/2 times 1/2 times 1/2. You multiply it when you're multiplying fractions, numerators by numerators, so 1 times 1 times 1 times 1 times 1. And denominators, 2 times 2 times 2 times 2 times 2. Well, 1 times 1 is always going to be 1 no matter how many ones you put up there. 2 times 2 is where we're going to have to calculate that math. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Therefore, we get the fraction 1 over 32. Anything that is a 10 as our base is going to be considered what we call our power of 10, in which you multiply that value by itself that many times. So 10 to the third is 10 times 10 times 10. There's a quick little shortcut when it comes to our powers of 10. You take this number of zeros and you simply use the exponent as the indicator of what that answer is going to be. So 10 to the third power means it's going to have a 1 and 3 zeros. 10 to the fourth power, 1 and 4 zeros. 10 to the fifth power, 1 and 5 zeros. See the pattern there. Now, our product property of exponents is based on those fundamental principles that we just practiced in example 1. The product property of exponents says that if you've got two sets of exponents that have the same base, see how it's x in each of the base portions of this equation, you actually can take those exponents up here, m and n, and you add them together. So when the exponents are being multiplied by each other, the exponents themselves up in the top actually get added together to give us our overall value for that exponent before we would then calculate. So here's the algebraic expression. In letter A, x to the fifth times x to the seventh times x squared. Now notice it's x, 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 therefore it's 5 plus 7 plus 2. 5 and 2 is 7, 7 and 7 is 14, so I get x to the 14th. Letter B, you've got m to the third times m to the second times m to the fourth times n to the sixth times n to the seventh. Now, our product property of exponents only works when the values that are in the base are exactly the same. So the m's could be added together and the n's could be added together, but not all together in one. So 3 plus 2 is 5, plus 4 is 9. Those are m to the 9th power, and then n is n to the 6th plus n to the 7th. 6 plus 7 is going to give us n to the 13th. It shows you how you would calculate that right down here. Example 3 has a way in which it wants to present this in a word form, and this word problem is actually quite confusing because it starts to talk about flops, this amount of computing power that is a calculation of what the computer can actually operate at. We're going to focus on the exponent and the base of that exponent itself to plan out this problem. Okay, so it says in 2006, the fastest supercomputer performed topped one at about 1 pflop, so that's how fast it processes, just a term for that. 1 pflop is equal to 10 to the third t-flops. Each t-flop is equal to 10 to the 12th flops. So basically, there are different conversions between these values that they're giving you. Again, we're going to focus on the exponent. So it asks us to solve this problem. You're going to then set up that multiplication with our product property because they have the same base, 10, and a different exponent, 3 and 12, you add those two together. 10 to the third times 10 to the 12th is 10 to the 15th. Now, doing a problem like this seems a lot easier than trying to figure out the calculation between these values. That's just to try and kind of strain our brain a little bit, do some critical thinking with a word problem in math. Once we get it broken down into that numeric expression, it's easier for us to try and calculate. Take a look at our lesson practice problems for lesson 3, and then you'll get to your assignment for the day. It asks you to simplify each expression in which you would actually practice and do that calculation. 6 to the 4th is 6 times 6 times 6 times 6. You can calculate that because it might be on your quiz tomorrow. Letter B, 1.4 squared. Even though it's a decimal, you would write this out as 1.4 times 1.4 and do the calculation. Letter C, 2/5 to the third power means you're going to write both the numerator and denominator out 3 times, so 2/5 times 2/5 times 2/5. Multiply 2 times 2 times 2 to get 8. 5 times 5 times 5 would get you 8 over 125. Letter D, 10 to the 6th, we've got a power of 10. We know that we can write a 1 and then 6 zeros behind that answer, so that actually gives us an answer of 1 million. Letter E, here's where we apply that product property of exponents. W to the third times W to the 5th times W to the 4th. They have the same base, www, like it's an internet website. 3 plus 5 is 8. 8 plus 4 is 12, so W to the 12th for that calculation. Lesson practice problem F has 2 different sets of variables, y's and z's. And we know that our product property only allows us to add the y's together, and then it adds us the z's together separately, and then we can write those as a multiplication between them. So y to the 6th plus y to the 5th, 6 plus 5 is 11, y to the 11th. Z would be 3 plus 11 plus 2, 3 and 11 is 14, plus 2 is 16. So you'd have y to the 11th, z to the 16th. Let's take a look at our assignment for Wednesday. You can see here on our weekly assignment checklist, the digital copy that is found on Google Classroom, the link to our IXL activity. If you want to get to that IXL assignment from this, you can just click directly here and it will link you to that. If you're going through Clever, I want to show you that there's a way in which you have to actually go about finding this assignment. This may be a good way to log into IXL, but not necessarily to find the assignment itself. You click on this app, it'll take you to IXL. When it takes you to IXL, it doesn't actually bring you to that specific skill that's been assigned to you. Okay? You would have to obviously know what the skill is that you're practicing, and this is going to look a little different because this is the teacher page. My advice would be to use Clever to sign into IXL by one click, and then go back to your weekly assignment checklist to get into that IXL assignment, or to use the link that's provided on your Wednesday page. So Wednesday, Lesson 3, Simplifying Expressions. You'll see that I have the IXL assignment listed here as well. Now that I have 1, 2, 3, 4, 5, 6 IXL assignments, let's actually practice with one of those examples. This is V.4, multiplication with exponents. Simplify the expression using positive exponents. I've got the same base, b and b, so my answer is going to be b. And then 8 plus 2 is 10. Now if I type in 10, that's going to give me an incorrect answer because it's not in the right form. Notice this didn't make an exponent. You probably figured out that this little button around here, if I click this, it creates that exponent, lifts that number up, and now I can type in the appropriate answer. Try that one more time. W is my base, W times W. We're going to add those two values, 3 and 4. Is going to give me, click the exponent button, 7. Now I'm going to click this little teacher preview here to jump a level to see what's going to be more difficult for you to experience. So you've run into this problem. Take a look at Mr. Shane's example. You've got h to the 0 power times h. This technically has a 1 here, and you would add 0 plus 1. I've got h to the 1. Submit. Got that correct. 0 power plus 13 is 0 plus 13. C to the 13th. Submit. Well done. What if it's a negative exponent? Well, the same rule applies in our product property that they have the same base. Now you're going to say that this is a 1 plus negative 5. Now when we're doing positive and negatives, you're going to get into what would be addition or subtraction. I always like to use two phrases when I'm dealing with positive and negative numbers, addition and subtraction. It is same sign sum, different different subtract. So 1 is a positive number, negative 5 is a negative number, different different subtract. So 5 minus 4 is going to give me 4, but that's a negative number. So negative 4 is my answer. Got it right. Anything plus 0 is f to the 6th, going to remain the same. I jump another level, or if I take a look at another example of a negative problem, I've got v as the base. They are the same sign, so same sign sum. 47 plus 62, keep it negative. 47 plus 62 is 109. Check if we got that right. Excellent. That would be the most difficult set of problems that you're going to complete. Again, you're working to get that SMART score all the way up into the 80s, 90s, or 100. Take your time, do your best, show me you've got this mastered.